Good afternoon. My name is Alexey Reznichenko. I am a student of National Technical University Kharkiv Polytechnic Institute. I study at the Department of Lifting and Transporting Machines and Equipment. My specialty is the engineering logistics systems. The topic of my scientific work is a calculation scheme for research of stability of collapsible racks. The work is devoted to the development of methods for analyzing the stability of collapsible pallet racks. These designs are adapted to the minimum size of the space they occupy. They also provide convenient access to goods, in order to place the maximum amount of cargo in the minimum area. High requirements are required to the design and calculation methods of racking systems. The finite element approach is proposed as a research method. This approach fully takes into account all the features of the elements and how they are combined in a prefabricated structure. The purpose of the work is the development of the calculation scheme of the section of the pallet collapsible rack. Calculation of rack stability is required. We need to take into account the design features of the components elements of the rack. During calculations, this model will require significant computer resources of the computing system. In the study, it was built. Fig 1 is an accurate shell model. During the calculation, the coefficient of the reserve of stability of the rack section and the first form of loss of its stability were determined. The result of the calculations are presented in Figure 1. As can be seen from the above figure, the first form of loss of stability is the bending form of general loss of stability. The stability margin factor is 7.25. This result was obtained with the maximum approximation of the calculation scheme to the real design. All elements were modeled by elastic shells. Fastening parts were modeled by elastic three-dimensional bodies. Bolted connections of the braces with the racks and the connection of the brackets of the load beams with the racks were taken into account too. Such an accurate calculation required serious computer resources. The dimensionality of the task was more than 8 million equations. The use of such a calculation scheme when building a model of multi-sectional rack will lead to the need for large computing power. Therefore, simplification of the calculation scheme becomes relevant. There is a need to reduce the size of the task. But the simplification should not significantly affect the accuracy of the calculation results. Thus, it's necessary to proceed to the construction of a simplified calculation scheme of the rack section. The first simplification is the replacement of some fastening parts with absolutely rigid bodies. And the second simplification is the replacement of braces and beams with the simplified beam elements. On Figure 2, you can see is a simplified combined model. Then we compared the stability of these two models. The efficiency of using the proposed simplification system was proven. When comparing, we found that the introduced system of simplifications made it possible to reduce the calculation time by almost half, and at the same time the stability coefficient increased only by 7%. As a result of the conducted research, we received a simplified calculation scheme of the pallet rack section. This scheme takes into account all of features of all elements of the rack and the nature of all connections. The simplification system consists in the fact that the fastening parts are represented by completely rigid bodies. Also, braces and load beams are represented by simplified beam elements. The resulting simplification scheme can be used to calculate the stability of multi-section structures. And at the end of my report, I would like to thank my technical supervisor, Rubashka Vladimir Petrovich. I have finished my report. Thank you all for your attention.